All right, so we're going to be looking at the integers and then the order of operations. And with math, I always like to start with the definition. We have very precise definitions in math, and this enables us to go back and look at a definition and see if something fits that definition or not. The definition of the integers is the set of numbers that contain what we call the natural numbers, which are also sometimes called the counting numbers, the ones that we learned how to count with, 1, 2, 3, 4, and so forth. The integers include all of those, what we call the natural numbers. They include 0, and then they include what we call the opposites or the negative of the natural numbers. So here we have a list of all of them. So starting with 0 in the middle and going from 1, 2, 3 on infinitely in that direction, and then going to the left of 0, -1, -2, and going infinitely in that direction. And then we further break them down and we call the negative ones the negative integers, the positive ones the positive integers. And notice that 0 doesn't belong to either category. It's not negative, it's not positive, it's 0. We sometimes also will talk about 0 and the positive integers, and we call those the non-negative integers. Or we might talk about 0 and the negative integers together as a group, and we would call them the non-positive integers. We often visualize this set of numbers using a number line, and we put 0 in the middle, and then we put the positive integers on the right, moving bigger as we move to the right, and the negative integers on the left, moving bigger as we move to the left. And one thing to really notice is that sometimes it is a little bit hard to conceptualize that -1 is actually bigger than -2. And -2 is bigger than -3. So if you notice, if you think about ignoring the negative sign for a minute, a bigger number part here with a negative in front of it means a smaller number. So -1,000,000 is way out here, a teeny, teeny, tiny number. And then we can think about graphing these numbers on the number line. So if I had questions like to graph these, I would start with a number line, and then I would just put dots. So -3 would be right here. And I would draw a dot there. And 4 would be to the right of 0 over here. And then right in the middle of my number line is 0. So that's all we mean by graphing or plotting the points. Now, when you look at the number line, again, notice that -4 is further to the left of -1. That means -4 is smaller than -1, or in math we say less than -1. And also, -1 is bigger than -4 because it's to the right, or you would say -1 is greater than -4. And we usually write these expressions, instead of writing words, we use symbols. The symbols that we use are called inequality symbols. This one over here on the right means less than. This one over here on the left means greater than. One way of remembering this, you might have even learned in grade school, or if you have children who are in grade school, you might have noticed that this is often taught by saying, if I put two numbers, 1 and 2, the symbol wants to eat the bigger one, so the mouth or the bigger side. I always just think of it as the bigger side. The bigger side points to the bigger number. So 1 is less than 2. And notice if I flip those around, I put the 2 over here and the 1 over here. Now the bigger side of the symbol has to point to the bigger number. So now I have 2 is greater than 1. And we could do some examples here. So when you're doing problems like these, you just think to yourself, okay, which number's bigger? Well, if one's negative and one's positive, the positive one's going to be bigger. So I'm going to put the bigger part of the symbol this way. And I have -4 is less than 3. Now, when they both have negative signs, it's a little bit trickier. Remember, the bigger one when they're negative is the one that's actually closer to 0. Another way of thinking about it, the one that's further to the right. So on the number line, -5 is further to the left. So the bigger number is -1. -1 is greater than -5. For this one, I have -5, which is further to the left than -2, so -5 is less than -2. And then for this last one, any negative number is going to be smaller than 0, which means 0 is the bigger one. So 0 is greater than -3. We also sometimes combine the less than or the greater than with an equal sign, like we have here. And we read this less than or equal to. So A is less than or equal to B. Some examples, 2 is less than or equal to 9. But notice also that 9 is less than or equal to 9. It doesn't have to be both. It only has to be one. And it is equal, so 9 is less than or equal to 9. We can also combine that equal sign with a greater than, and we read this as B is greater than or equal to A. And again, some examples, 9 is greater than or equal to 2, because 9 is greater. It doesn't have to be both. And 2 is greater than or equal to 2, because 2 is equal to 2. It only has to be one or the other. The next thing we're going to talk about is the absolute value of an integer. And we use the notation, these vertical lines. So a number or expression with vertical lines on either side, we read the absolute value of A. And the absolute value is defined to be the distance from the number to 0 on the number line. So notice that an absolute value is never going to be negative. Let's see if we have a number line here. Here we go. So for some examples, the absolute value of -3, I find -3 on the number line, and then I count how far away is it from 0. Well, it's 1, 2, 3 away from 0. So the absolute value of -3 is 3. The absolute value is of 5. I'm going to locate 5, and then I see that it's 5 away from 0. And then the absolute value of 0, well, it's exactly on 0, so there's no distance between it and 0. The absolute value of 0 is 0. A lot of people just remember this by thinking that when we take the absolute value of a number, we get rid of the negative sign if there is one. It's kind of another way of thinking about it. Now that we understand absolute value, we can talk about adding integers. When integers have the same sign, we're just going to add their absolute values. So think about adding them up without thinking about the signs. And then whatever sign the two numbers had, we keep. So when we add -11 and -15, we think, what's 11 plus 15? That's 26. And since they were both negative, we're going to keep that negative sign. Another way to think about it is I've had a lot of students that say thinking about money helps them. So you might think if you owe $11 on one credit card and you owe $15 on another credit card, then in all you owe a total of $26. When one has a negative sign and one has a positive sign, now what we have to think about is that we have to think about what's the difference between the absolute value of the two numbers. And then the bigger one is going to influence the sign of the result. So the absolute value of -13 is 13. So I'm going to subtract 13 minus 4, that's 9. But since I started with a negative number, now my answer is going to be negative. So -13 plus 4 is -9. And you can think about that with money again. If you owed $13 on your credit card, that would be a -13. And then if you made a $4 payment, well, now you only owe $9, which we represent with -9. In this example, we have 13 plus -6. Well, now the 13 is bigger, And this is really just the same as 13 minus 6. But I can also think of it as if I have $13 and then I spend $6, that would be represented by negative 6. Now I have $7 left. If you kind of think about these rules as you're doing the problems, I think it can be really helpful. Some people might also think about temperatures. So that's another way to think about things. So negative 11 plus negative 15, I could think about if the temperature is negative 11 and then it goes down 15 degrees, now it's down to negative 26. On the other hand, if the temperature is at negative 13 and it goes up 4 degrees, it's going to move up to negative 9. And if the temperature is 13 degrees and it goes down 6 degrees, it's going to end up at 7. So all of those are some examples that can kind of help you conceptualize why the rules of negative and positive numbers are what they are. Or better word is really properties, because it's the way that the numbers work, not just some arbitrary rule that someone came up with. To think about subtraction, we're going to first introduce some new vocabulary. And you've maybe heard about an inverse. An inverse is just an opposite operation. And for addition, we have what we call the additive inverse because we use it when we're performing addition. And additive inverses are just opposites. You may have heard that word before. And they lie on the opposite sides of 0 when we put them on the number line. And when we add up these opposites or additive inverses, they add up to 0. So for example, 18 plus negative 18 is 0. They're equally 18 units away from 0 on the number line. So they lie on opposite sides. And if we add them up, we get 0. So 18 and negative 18 are opposites. Same thing for negative 7 and 7. And also really for any integer a, we just change its sign. So you can think of take an integer, change its sign, and now you have its opposite. So if the integer I pick is negative 5, if I change the sign, I get 5. That means the opposite of negative 5 is positive 5. It's important to know what an additive inverse is because the way that we subtract integers is we just add the opposite, the additive inverse. So I can write a minus b is the same as a plus negative b. So taking away b is the same as adding the opposite of b. And we also use the word difference to represent subtraction. So I might say the difference of a and b is the sum of a and the opposite of b. Some examples now. For the first one, I have 17 minus negative 11. So I can think of that as adding the opposite of negative 11. And the opposite of negative 11 is 11. So 17 plus 11 is 28. Another way of kind of thinking about this in terms of money is that if I owe $11 and you're going to take away that debt, now you basically gave me $11. For negative 18 minus negative 5, I'm going to keep negative 18 the way it is, and then I'm going to add the opposite of negative 5, which is 5. Now I have to think back to how did I add the integers? And I added them when one is negative and one is positive by first thinking of what's the difference, subtracting them, 18 minus 5, and that gives me 13. And now I keep the sign of the bigger one. I owed someone $18. I paid off $5. Now I still owe $13. For this one, I'm going to rewrite it also. Negative 18. And now I'm going to add the opposite of 5. So I was subtracting positive 5. So now I'm going to add the opposite of that, which is negative 5. So now I'm adding two negative numbers. I can just add their absolute values, which is 23, and keep the sign. Negative 18 minus 5 is negative 23. When we multiply numbers, you can think of it as repeated addition. Or, so for example, 3 times negative 4, you can think of adding negative 4 to itself 3 times. Or you can think of starting at 0 and then subtract 4, subtract 4, subtract 4, and you get to negative 12. Another way of kind of just remembering this, I guess, not necessarily conceptualizing it, is to just remember that when I multiply a negative times a positive, negative times positive, I get a negative. And a positive times a negative, I get a negative. So when the signs are different, my result is negative. When the signs are the same, positive times positive, I get a positive. And negative times negative, I get a positive. So different signs, negative result, same signs, positive result. And if you can remember that, then all you have to do is remember how to do multiplication. First example, 7 times negative 5. I do 7 times 5, which is 35. And then because they both have opposite signs, my result is negative. For negative 6 times negative 11, I first multiply 6 times 11. That's 66. In this problem, I have a negative times a negative. The signs are the same, so the result is positive. You also want to remember that when we multiply by 0, we always get 0. Doesn't matter if it's positive, negative, or 0. Multiplying by 0 will always give me a result of 0. What about if I add in some extra numbers? So instead of multiplying 2 numbers, now I have 3 numbers. So if you think about what's going on here, I'm first going to multiply 2 times 3, which is 6, times 5, which is 30. And now I'm going to think about the sign. If I were to multiply these two together, I'd have the same signs, which would give me a positive result. Now I have a positive result that I'm multiplying by a negative result, opposite signs, so my result is opposite. And another way of thinking about this is anytime I have an even number of negative factors, they'll all cancel each other out because pairs of 2 cancel each other out. Anytime I have an odd number of factors, there's going to be one leftover odd one. So all the even pairs will match up and cancel each other out. And then I'm left with the odd man out. So an odd number of negatives gives me an odd result, and an even number of negatives gives me not an odd result. An odd number of negatives gives me a negative result, and an even number of negatives gives me a positive result. That's what I meant to say. We'll take a quick look at exponents now. Just like multiplication is repeated addition, exponents are repeated multiplication. That means that if I write 3 to the 4th power, what I'm really saying is take 3 and multiply it by itself 4 times. 3 to the 4th is 3 times 3 times 3 times 3, which is 81. Now, when we throw some signs in there, here's where we have to be careful. For this problem, this is telling me to take negative 6 and multiply it by itself 2 times. And remember, a negative times a negative is a positive, and 6 times 6 is 36. So the answer to this one is 36. For this one, though, this one is saying I'm going to multiply 6 times itself twice, and then I'm going to change the sign. So notice here I have a negative times a positive, which gives me a negative result, negative 36. So be very careful with negatives If we have an even power here, if we have parentheses, we're going to end up with a positive result. If we don't have parentheses, we're multiplying this number, the positive number, by itself, and then we're changing its sign. So we get a negative result. For odd powers, doesn't really matter. I would get the same result. I mean, it does matter, but I get the same result. So this is just going to be -5 times itself 3 times. And I have an odd number of negatives, which means my result will be negative. And then I can multiply 5 times 5 times 5 to get 125. And then for this one, we've got parentheses around the -2, which means we're multiplying -2 by itself 4 times. That's an even number of negatives, which means my result will be positive. And then I can multiply 2 times itself 4 times to get positive 16. That brings us to division. And the nice thing about division is that because of the way multiplication and division work, they're basically opposites of one another. It has the same rules as negative, or the same, sorry, as multiplication, or I should say the same properties. So a positive divided by a positive gives me a positive. A negative divided by a negative gives me a positive. Same signs, positive result. If I divide a negative by a positive, I get a negative. And if I divide a positive by a negative, I get a negative. Different signs, negative result. We can write division a couple of ways. We can write it this way with this division symbol, and we can also use a fraction bar. So this also means -12 over 4 also means -12 divided by 4. And both of them have the result of -3. A few more to kind of think about. Okay. 80 divided by -4. I just think 80 divided by 4 is 20. The signs are opposite, so the result is negative. Here, -45 divided by -3, the signs are the same, so my result is positive. And then we have the two special cases, okay? 0 divided by any number is 0. You can think about if you have nothing and you separate it into a certain number of categories, you still have nothing. Another way of thinking about that is -5 times 0 is 0. So 0 divided by -5 is 0. This one is undefined. -8 divided by 0. We can't divide anything by 0. If you've ever tried it on your calculator, it'll give you an error. A lot of times students struggle to remember which is which here, so it can be helpful to think about what division really means. I also have a clever way that one of my students came up with, which is to remember that when the 0 is under the fraction bar, it's underfined. I thought that was pretty cute. And it seems to help people remember that. Can't have 0 under the fraction bar because it's underfined. The next thing that we're going to look at is the order of operations. And our book helps you to remember this order by using the mnemonic device PEMDAS. The P stands for parentheses. And you may have also learned this with a G for grouping symbols, and really it includes not only parentheses, but also brackets and braces, which I'm not very good at drawing. Absolute value signs are also included. And also fraction bar. So anything on top of the fraction bar is done before, and everything on the bottom is done before we do this division. So anything that uses grouping symbols gets done first. After we've done all of the grouping symbols in our expression, then we look for exponentials, and that's what we do next. After we've done all the exponentials, we move to multiplication and division, so M and D. These are not done, all the multiplications and all the divisions, they're done in the order they occur, working from the left to the right. So I sometimes do that to remind me. And then the last step is additions and subtractions, and they're also done left to right. And if we do things out of order, we can very often come up with an answer that is not what we are expecting and not what the expression meant for us to do. So you want to make sure that you follow this order of operations very carefully. Let's look at some examples. The first thing that I'm looking for are any parentheses or grouping symbols. And I don't see any. So I'm going to move on to the exponents, and I'm just going to circle anything that has an exponent. And now I'm going to rewrite this expression, and I'm going to replace the exponents with their equivalents. So 6 squared is 6 times 6, which is 36. I'm going to leave everything else alone. I don't have the minus 24 or the division sign circled, so I'm going to leave those alone. And now I have 2 squared, which is 4. And then I'm going to copy down the rest, times 3 plus 1. I'm going to switch colors now so you can see what we're doing next. The next thing I'm going to do is multiplication and division. So I'm looking for any division or multiplication. Okay. And so I'm going to leave everything else alone. 36 minus, and then working from the left to the right, you can see this division came first. So I have 24 divided by 4. Notice I copied the negative sign down, so I'm ignoring it for now. And 24 divided by 4 is 6. I'm just going to keep this one for now and copy everything else down. And so I still need to do this multiplication. So now I'm going to leave the 36 alone, the negative sign, and now I'm going to do 6 times 3. That's 18 plus 1. And now I can work my subtractions and additions left to right again. So first, I do this subtraction, which gives me 18, and I copy down the rest. And then finally, I just have one operation left, so I can add them, and I get 19. And if you entered that in that exact order on a calculator, you should get the same answer. That's all we have in the PowerPoint. The next thing that I want to look at is some examples from our book. So I'm going to share this part of the screen. And let's see, what did I do wrong? Oh, I know what I did. Try that again. Let's see. I want, yeah, I'll just do this here. And then this, oops. Okay. So the first thing that I wanted to look at here is some examples from the book. And this is one of the similar problems that you might see in the homework that is tends to be more challenging for students. So let's see if we can kind of break it down. What do we have on this graph? We've got a number line. So here's 0. Over here, we've got our negative numbers, and over here, our positive numbers. And then we have some points that are labeled. And what these are representing is the years of life gained or lost by particular habits. So, on average, if someone smokes cigarettes, they are losing 15 years of life. On the other hand, if someone has a blood relative who's 95 years or older, they can expect to live 10 years longer than the average life expectancy, which at the time this was written was 75 and a half, 75.1 for men and 80.5 for women. So some example questions here are asking about the difference in lifespans. And remember, difference in math means subtraction. Difference means subtraction. So if I said, what's the difference between 2 and 3? 2 minus 3. Remember, when we subtract 2 minus 3, we can think of this as 2 plus -3. And then to add these two numbers, we're going to subtract their difference, which is 1. And then because this one has a bigger absolute value, we keep its sign. So the difference between 2 and 3 is -1. So keep that in mind as you're working on these problems. Let's look at this example. What's the difference in the lifespan between a person who regularly works puzzles and a person who eats red meat more than twice a week? So someone who works puzzles is right over here. They have a difference in lifespan. They gained 3 years. Well, that's good news for me. I like to do puzzles. Someone who eats red meat more than twice a week, they're over here at -5. And then let's go back and read, what were we asked? The difference between a person who regularly works puzzles, that was a positive 3 years, and someone who eats the red meat, -5. And notice these are the two numbers that we're taking the difference of. The difference is subtraction. So what this is saying really is, what is 3 minus -5? And remember, when we're subtracting a signed number, we're going to add its opposite. So 3 plus +5, which gives me a difference of 8 years. And notice that if I count along the number line, here's 1, 2, 3, 4, 5, 6, 7, 8. Now, why didn't that work out? Oh, I went too far. Oh, I read this wrong. Let's fix this, okay? So we're gonna, whoops, erase this. Start over. The method's correct. I just read the graph wrong. So someone who regularly works puzzles is right here between 4 and 5, between 4 and 6. So that's actually a +5. And then the person eating the red meat is -5. So that means the difference is going to be between someone who works puzzles, 5, and someone who eats the red meat. So what we really wanted to do was 5 minus -5. That's going to be the same as 5 plus +5, which is 10. And if we count that difference, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure enough, there's 10 units between those 2 points on the number line. It's another reason why I like to check my work, because then I notice little mistakes like that I make. Let's do one more example of these. What's the difference in the lifespan between a person with less than 12 years of education and a person who smokes cigarettes? So first I'm looking for less than 12 years of education. That's right here, -6. And a person who smokes cigarettes is right here, -15. Okay. And I want the difference. So -6 minus -15. That's going to be -6 plus the opposite of -15, which is -6 plus 15. And to find that difference, I'm going to subtract absolute values, which gives me 9. 15 minus 6 is 9. And then I keep the sign at the number with the larger absolute value. So it's +9. Let's check that one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So a 9-year difference between someone who smokes cigarettes and someone who has less than 12 years of education. Hope that will help you with solving some of those problems. But if you have more questions about that, please definitely reach out. Now I'm going to move to the end of the chapter, which is page 275. And we're going to just do a couple of example problems here. Let's see. So we did the addition and subtraction. So what I wanted to do is a couple more of these order of operations questions. And let's do one that has an exponent thrown in there. Let's see. How about this one here? So I've got -3 minus 6 plus 8 cubed minus 5 minus 3 plus 5. The first thing that I want to do is those parentheses or grouping symbols. And so I've got one right here, and I've got one right here. So I'm going to rewrite this. I'm going to leave the -3 alone. -6 plus 8. I'm going to subtract the absolute values, which is 8 minus 6. That gives me 2. And I keep the sign that is on the 8 because that's the bigger absolute value. So that becomes 2. -6 plus 8 gets replaced by 2. Everything else I'm leaving alone. -3 times 2 cubed minus 5 times. And now I have to do -3 plus 5. Very similar. I can think of this as just 5 minus 3. So 5 minus 3 is 2. And 5 has a larger absolute value than -3, so I keep that a positive, and I also have to cube that one. I've done my grouping symbols, my parentheses, so the next thing I'm going to do are exponents. And I've got one here, and I've got one here. I'm going to leave the -3 alone, and now I'm going to do 2 cubed. That means take 2, multiply itself 3 times. 2 times 2 times 2 is 8. Minus 5, and I have 2 cubed again, so I know that's going to be 8. The next thing are my multiplications and divisions, and I've got a couple of multiplications, so I can do those from left to right. I'm going to keep the negative sign, and then 3 times 8 gives me 24. I'm going to keep the negative sign again, and then 5 times 8 gives me 40. So now I'm just left with subtractions, and I do those from left to right. And I want to think of this as -24 plus the opposite of 40. So -24 plus -40. And now I can just add up the absolute values and keep the sign since they both have the same signs. That gives me negative 64. All right. I hope this lecture has been helpful for you. If you have any questions, you can reach me at jane.keller@joyce.edu. You can also ask your professor or me if I'm your professor. That gives you only one choice. But yes, please reach out if you have any questions, and I will see you next week.